Now we'll be looking at the gate important questions on homogeneous and non-homogeneous system linear equations. Please look at the part 14 and 15 for better understanding. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. The next question. Question a system of linear equation 4x plus 2y is equal to 7, 2x plus y is equal to 6 has. You have to find whether it has an unique solution, infinite solution, one solution, exactly two distinct solutions. Okay. Now you can see that this is a non-homogeneous equation. So we have ax is equal to b. Now we're writing all the values of a, x and b. We know that a is equal to nothing but 4, 2, 2 and 1. Right. Then x is equal to nothing but x and y. And b is equal to 7 and 6. Right. This is the a value, this is x and this is b. Now we have to find whether it has a unique solution, no solution or infinite solution or exactly two solutions. For this one we have to find the rank of a and rank of c. Depending on this one we can say the solution, right? So c is nothing but combination of a and b, right? So first we have to find the rank of a. In this particular matrix A, you can see that row 2 is equal to nothing but 2 times of an row 1. So do the elementary operation. So it becomes 2 times of an R2 minus R1. If you do it, then matrix A is equal to nothing but it gets as 4, 2, 0, 0. Right? So it is nothing but 1 cross 2 matrix. So rank of an A is equal to nothing but 1. So rank of A we got as 1. Now coming to C matrix. C matrix is nothing but combination of an A, both A and B. We have to find it out. It's nothing but 4, 2, 2, 1 with an A, 7 and 6. Right? So we're doing the same elementary operation. R2 is equal to nothing but 2 times of an A, R2 minus R1. Then we get an A matrix as nothing but 4, 2, and this is 7, this is 0, 0. Then 6 to the 12 minus 7, it becomes 5. Right? So this is nothing but 2 cross 3 matrix. So we get a rank of an A, C is equal to 2. You can see that rank of C is equal to 2, which is not equal to 1. So rank of A is not equal to rank of C. Right? So it has no solution. So answer the option B. For the following set of simultaneous equation, okay, it is a non-homogeneous equation. You have to find whether it has an unique solution or infinite many solution or incompatible or finite number of multiple solution. So they are given the non-homogeneous equation. It's nothing but Ax is equal to B. Now we'll be writing the Ax and B matrix. So coming to A matrix, it becomes 1.5 minus 0.5, and this is 0, and this is 4, this is 2, this is 3, and this is 7, 1 and 5. Right? And coming to X matrix, is given as X, Y and Z. Right? Now coming to the B matrix, it is given as 2, 9 and 10. Right? This is an A matrix, this is an X matrix, this is an B matrix. Now first what you do is nothing but find the determinant of a matrix A. Determinant of a matrix A. If you get it as 0 or not 0, okay, by that one we can find it out whether it has an unique solution or we can find it out whether it is an incompatible or infinite many solution. Right? First we'll find the determinant of a matrix A. Okay, by that one we will define the rank of matrix. Now it becomes 1.5 into 5 2s are 10 minus 3 plus 0.5 into 20 minus 21 plus 0. So which is equal to 1.5 into 7 minus 0.5, which is equal to 10.5 minus 0.5, which is equal to 10. which is not equal to 0. So rank of a matrix A is equal to nothing but 3. We got it, right? Now coming to C matrix. C matrix is a nothing but combination of both A and B, right? Now in this particular case, A determinant is not equal to 0. So this particular rank is 3. In this particular matrix, it becomes nothing but 3 cross 4 matrix. So we can say that directly rank of an C is equal to nothing but 3 only. Okay. Now we can see that rank of A is equal to rank of C. So it has an unique solution, right? So answer is option A. Come next question. For what value of A, if any, with the following system of equation in x, y, and z have infinite many solutions? So they are given the three system equations, right? It is an homogeneous equation. So it becomes Ax is equal to B. Now we have to find the value of A such that it has an infinite many solution. Means rank of A is equal to rank of C, which should be less than n. What is n? N is nothing but an order of A and C. And C is equal to nothing but combination of A and B, right? So first we'll be writing down the matrices. So A is equal to nothing but it becomes 2, 3, 0. This is 1, 1, 1. This is 1, 2, minus 1, right? And coming again, B is equal to nothing but we get as 4, 4, and A, right? And C is equal to nothing combination of both A and B. So it becomes 2, 3, 0, 1, 1, 1, 1, 2, minus 1, and 4, 4, and A, right? First we define the rank of an A. Okay. So we'll be doing some elementary operation such that we'll get in a 0 somewhere and we'll be getting in a value of an a rank of an a matrix A. So here you can see that R3 is equal to nothing but to make this particular value 0, right? In row echo form, it becomes R3 minus R2, right? And similarly, R2 is equal to nothing but 2 times of R2 minus R1. When you do it, then A is equal to nothing but you get the matrix as 2, 3, 0, and this one becomes 0. This becomes minus 1, this is 2, and this is 0, this is 1, and this is minus 2, right? You can see that row 2 is equal to nothing but row 3, right? Both are same. So when you add it, it becomes 0. So rank of an A is equal to nothing but you get as 2, 3, 0, 0 minus 1, 2, and this 0, 0, 0, right? From this one we can see that rank of an A is equal to 2. So here we got the rank of an A as an a 2. Now in the case of an C, also we should get an as an a 2, right? So by doing an some elementary operation, okay, we're doing the same operation here also. Then C is equal to nothing but we get as 2, 3, 0. This is 4. Here it becomes 2 minus, we are doing the same operation, okay, here R2, it becomes 0. This is nothing but minus 1. This is 2, right? It becomes 8 minus 4, so it becomes 4 only. Again here what you are doing is nothing but these two values we are subtracting, so it becomes 0. This becomes 1, this becomes minus 2, and this is nothing but it becomes A minus 4, right? Now what we do is nothing but we are just adding both of them. So C is equal to get as 2, 3, 0, 0 minus 1, 2, it becomes 4, this is 4, and this is 0, 0, 0, and this becomes C, right? Now this is the rank of an A, this is a matrix. So rank of an A is nothing but 2, we got it. Now the whole rank, if you consider a value other than 0, then rank will becomes 3. But it should be 2 only, right? As you know that rank of A should be equal to rank of C. So when A is equal to 0, then rank of C is equal to 2, right? Then only it get satisfied. So value of A is nothing but B, option B, 0. The next question. The question is, let A be in a 3 cross 3 matrix with a rank 2. Then Ax is equal to 0 has. It is asking for whether it has only the trivial solution Ax is equal to 0, or one independent solution, or two independent solution, or three independent solutions. Okay. It is given that A is nothing but 3 cross 3 matrix, right? Now if you see the trivial solution, where do we get it? When the rank of a matrix A is equal to n, which is equal to nothing but 3 only. If you consider A is an n cross n matrix, which is a 3 cross 3 matrix, then we get a trivial solution, right? But it has given us nothing but 2. So it does not have a trivial solution. It is a non-trivial solution. So option A goes. Now we are finding for independent solution. The number of independent solution is given as n minus r, where n is nothing but order of a matrix, r is nothing but rank of a matrix. So it is given as 3 minus 2, which is equal to nothing but 1. So it has one independent solution. So answer is option B. Now coming to next question. The question is, let A be an n cross n real matrix such that A square is equal to I and Y be an n-dimensional vector. In a linear system of equation, Ax is equal to Y has. They are asking about no solution, unique solution, or more than one, but finitely many independent solution, infinite many independent solution. Now we are understanding this particular question. They are saying that A square is equal to I. They are given that A square is equal to I. And they are talking about a non-homogeneous equation. Ax is equal to Y, right? In this particular case, how to find the nothing but a no solution or unique solution or many solution? How to find it out? It's nothing but simply finding the determinant of a matrix E. Okay. If you consider this particular matrix, okay, the determinant of a matrix A square is equal to nothing but determinant of a matrix I, right? We know that determinant of a matrix I is equal to 1. Then we can say that determinant of a matrix A square is equal to nothing but determinant of A into determinant of a matrix A, which is equal to 1. Then we can say that determinant of a matrix A can be equal to plus or minus 1. Yes or no? But not equal to 0. So we got a determinant of a matrix not equal to 0. If determinant of a matrix is not equal to 0, then we can say that it has a unique solution, right? So answer is option B. Now coming to the next question. The question is, consider the following system of linear equation. Okay, and they are given the non-homogeneous equation given as Ax is equal to B, right? And this is nothing but A, this is X, and this is B, right? Now they are saying, notice that the second and the third columns of a coefficient matrix are linearly dependent. Means if you see this particular E matrix, it's in a column 2 and this in a column 3, right? And both of them are dependent. If you multiply this particular column 1 within a 4, it becomes equal to column 3, right? So they are saying that it is a linearly dependent. Now, for how many values of alpha does this polar system of equation has infinite many solutions? It is saying that you have to find the value of alpha. For how many values of alpha the system of equation has infinite many solution, it is asking, right? It is nothing but rank of A should be equal to rank of C. Then only we have infinite many solution, and it should be less than n. N is nothing but an order of an A matrix. Now A matrix is nothing but 3 cross 3 matrix, right? So it should be less than 3. Here A matrix is nothing but 3 cross 3 matrix, and C is nothing but, so is a combination of both A and B, right? So it is nothing but 3 cross 4 matrix. For this one, first we'll be finding the C matrix, rank of it. Here C matrix is equal to, it becomes 2, 1, 4, 4, 3, 12, 1, 2 and 8, and this one is alpha 5 and 7. Right, now we'll be finding the rank of a C matrix. Right, so we'll be doing some operations, elementary operations. If you consider the row 2, and this is in a row 1, and this is row 3, right? Now we'll be substituting such that we'll be getting 0 here in the row 1. So row 1 is equal to nothing but 2 times of row 1 minus row 2. R3 is equal to 4 times of an R3 minus R2, right? Then the matrix will be changing. It becomes 0, this is minus 1, then it is 8 minus 12, right? It becomes minus 4, and this becomes 2 alpha minus 5, and this is 4, 3, 12, 5, and there is nothing but 0, right? It becomes 5, this is 20, and this is 23, right? Now what we do is nothing but let R1 is equal to R1 plus R3 by 5. And the matrix becomes 0, 0, 0, and this is nothing but 2 alpha minus 5 plus 23 by 5, right? And this is 4, 3, 12, 5, and this is 0, 5, 20, and this is 23. Now this is an A matrix, right? And the whole thing is in a C matrix, right? You have to see that rank of A is equal to rank of C. So rank of an A, you can see that it is nothing but 2. So rank of A is nothing but 2. Now this should be equal to rank of C. When it will be equal to rank of C is nothing but when this particular term is 0. So it becomes 2 alpha minus 5 plus 23 by 5 should be equal to 0, right? So if you take an LCM, then it becomes 2 alpha plus 23 minus 25 by 5, right? Then becomes 2 alpha is equal to nothing but 2 by 5. 2 to get cancelled. Then we get alpha is equal to 1 by 5. When alpha is equal to 1 by 5, we can say that it has infinite many solutions. So for how many values of alpha is not there? Only for one value of alpha we get this particular situation, right? So answer is option B. Come next question. The question is, for following 3 vectors are linearly dependent if x is equal to. Now they are saying about a linear dependent. When the matrix would be linear dependent, where determinant of a matrix A is equal to 0. Now they are given the 3 vectors, right? So if you combine write this particular vector, then matrix A is equal to nothing but it becomes 1, 2, 1. Then this is x, 6, and this is x, and 3, 4, and 2, right? And determinant should be equal to 0. So find the determinant of a matrix A, which is equal to nothing but it becomes 1 into 6 2 is 12 minus 4x minus x into 4 minus 4 plus 3 into 2x minus x should be equal to 0. Now this is 0, so it becomes 12 minus 4x plus 6x minus 18 is equal to 0. So it becomes 2x, right? Minus 6 is equal to 0. Then x is equal to nothing but 3. So when x is equal to 3, then it becomes a linearly dependent. Now coming next question. The question is, for what value of alpha and beta the following simultaneous equations have an infinite number of solutions. Okay, and they are given a non-homogeneous equations, three equations. Now non-homogeneous equation is nothing but Ax is equal to B. Now we'll be writing the A, X and B matrix. So it becomes nothing but, here it is 1, 1, 1, this is 1, 3, 3, and this is 1, 2, alpha, right? And it is multiplied with an X value. X is nothing but given as X, Y, and Z, which is equal to nothing but B matrix. B matrix is given as 5, 9, and beta. Now this one should have infinite many solutions. Means it's nothing but rank of A should be equal to rank of C, which should be less than n. N is nothing but order of a matrix. Now A is nothing but 3 cross 3 matrix, right? And C is nothing but a combination of both A and B, right? So it becomes 3 cross 4 matrix. So it should be less than 3, order of a matrix. Now first we define the rank of a C, which is equal to nothing but, it becomes 1, 1, 1, 5, combination of both A and B, and 1, 3, 3, 9, and this is 1, 2, alpha, this is beta, right? Now we'll be doing an elementary operation, nothing but R2 is equal to R2 minus R1, okay? Then R3 is equal to R3 minus R1. Then the matrix we get it as nothing but 1, 1, 1, 5, and this is 0, 2, 2, 4, and this is 0, 1, alpha minus 1, and beta minus 5, right? This is a matrix, we get it. Now we'll be dividing R2 by 2. Then the matrix we get is nothing but, it becomes 1, 1, 1, 5, and 0, 1, 1, 2, and this is 0, 1, alpha minus 1, and beta minus 5, right? Again, what you do is nothing but subtract R3 is equal to R3 minus R2. And what do we get it? As nothing but matrices becomes 1, 1, 1, 5, and this is 0, 1, 1, 2, and this is 0, 0, alpha minus 2, and this is beta minus, it becomes 7, right? Now the rank of an C should be less than 3 when this particular two terms should be equal to 0. Then alpha minus 2 is equal to 0, and beta minus 7 should be equal to 0. Then we get to get a rank of C would be less than 1. So it is nothing but alpha should be equal to 2 and beta should be equal to 7. Now when alpha is equal to 2, then we can say that rank of a matrix A is equal to nothing but, it becomes less than 3, right? So when alpha is equal to 2 and beta is equal to 7, then we get a nothing but infinite many solution. So answer the option A. Now come to the next question. The question is, for set of equation x1 plus 2x2 plus x3 plus 4x4 is equal to 2, and 3x1 plus 6x2 plus 3x3 plus 2x4 is equal to 2. They are given two equations. This is equation 1 and this is an equation 2, right? So they are given two equations and they are saying that whether it is a trivial solution or no solution, or unique non-trivial solution, or multiple non-trivial solution. So generally if you see here, how many variables are there? The variables are nothing but x1, x2, x3 and x4, and number of equations are nothing but 2. So it is nothing but number of equations are less than number of variables. So we have a multiple number of many solutions. So answer the option D. Come next question. let A be M cross N matrix, B N cross M matrix. It is given that determinant of I of M plus AB is equal to determinant of I of N plus B, where I of K is K cross K identity matrix. Using the above property, the determinant of a matrix given below. If you consider this particular matrix as A, okay, now we have to find the determinant of a matrix A is equal to how much, right? Simply to say. Now this is a 4 cross 4 matrix, right? So it is a higher order matrix. How to find the determinant of a higher order matrix? So for that one, what you do is nothing but consider one element and make the other elements of a row or column as a 0. So what you do is nothing but when making this particular column elements as a 0, okay, all this particular 1 as a 0. How to do it? What you do is nothing but this is row 1, this is row 2, this is row 3, and this is row 4, right? Let row 1 is equal to nothing but row 1 plus row 2 plus row 3 plus row 4, and row 2 is also equal to row 1 plus row 2 plus row 3 plus row 4. Row 3 also equal to row 1 plus row 2 plus row 3 plus row 4, and row 4 is equal to also equal to row 1 plus row 2 plus row 3 plus row 4. What we are doing nothing but just adding all the rows. Then the matrix we get is nothing but it becomes 5. This is also 5. This is also 5. This is also 5. Right? And this is 1, 1, 1, 2, 1, 1, 1, 2, 1, 1, 1, 2. Now it be taking 5 is on a component. Okay. Then the matrix nothing but it is 1, 1, 1, 1. And below elements are nothing but 1, 1, 1. This is 2, 1, 1, 1, 2, 1, 1, 1, 2. Right. Now we'll be doing elementary operations such that this particular element, okay, below elements are nothing but 0. So we have to make this element, and this element as a 0. So this is a row 1, right? So we consider row 2 is equal to row 2 minus row 1, and row 3 is equal to row 3 minus row 1, and row 4 is equal to row 4 minus row 1. If you do this particular operation, then the matrix we get is nothing but 5 into, already 5 is there, right? 5 into the matrix, which is nothing but 1, 1, 1, 1. This becomes 0, this one becomes 0, this one is 0, and this is 1, 0, 0, 0, 1, 0, 0, 0, 1, right? Now we have to find the determinant of this particular matrix, right? The general thing that we do is nothing but we consider one element, right? It's nothing but minus 1 power I plus j into A of ij into determinant of the other elements, right? So one element is nothing but it is a11. So I and j are nothing but 1 and 1, right? So it becomes minus 1 power 1 plus 1 into A of ij is nothing but 1 into the matrix is nothing but we do not be considering this particular column and this particular row. Then the matrix is nothing but you get as 5 into minus 1 power 1 plus 1 into 1 into the matrix. The elements are nothing but it becomes 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is nothing but identity matrix I, right? So determinant of the identity matrix is nothing but 1, right? So which is equal to nothing but becomes 5 into it's 1 square minus 1 square. So it becomes 1 into 1 into 1, which is equal to 5. So determinant of a matrix A is equal to nothing but 5. So answer the option C. Go to next question. Question is considering A, which is nothing k, 2k, k square minus k, and k square, and vector x is equal to x1 and x2. The number of distinct real values of k for which the equation ax is equal to 0 has infinite many solutions. So it is talking about the homogeneous equation. Then we have ax is equal to nothing but 0, right? So it should have an infinite many solution. Then we can say that determinant of a matrix A should be equal to 0. So A matrix is given here. So defining the determinant of this one. That is K, 2K, K square minus K, and this K square. And determinant should be equal to 0. So it becomes K cube minus 2K into K square minus K is equal to 0. Take K common from the here. We get K cube minus 2K square into K minus 1 is equal to 0. Take K square common here. Then we get K square into K minus 2 into K minus 1 is equal to 0. Let us K square into K minus 2K plus 2 should be equal to 0, right? So we can say that one of the values of an A is nothing but K square is equal to 0. So one of the values is nothing but K can be equal to 0. The other value is nothing but equal to this one to 0. Then becomes minus K plus 2 should be equal to 0. Then K is equal to nothing but 2, right? So they are asking the distinct real values of an K is nothing but it can be 0 or 2. Then we have an infinite many solution. So answer the option 2.